Okay, so while you're getting signed in there and looking for the Pendulum lab, the purpose of today's lab is to confirm something that we've learned, okay? And that is what factors or variables might affect the period of a pendulum, okay? When we were brainstorming on the first day about what things could affect the period of the pendulum, a few things came up. Length, mass, gravity, and amplitude, okay? How far it swings. Since we can't manipulate gravity, we can't test that, okay? We can't just go, well, in this trial, gravity will be reduced to 6 meters per second squared. Because, well, that would be fun, okay? We can't do it. So there's no way to test that. So what we're going to test instead are length, mass, and amplitude. All right? We're going to see if any of those affect the period of the pendulum and how they affect it. All right? So this lab is actually going to kind of have 3 parts, because we're going to have like one part where length is our manipulated variable, one part where amplitude is our manipulated variable, and one part where mass is going to be our manipulated variable. So we're actually kind of doing 3 mini labs. Okay? So when we're doing our design, we kind of have to break it up a little bit. Okay? So I'm going to be a bit more forgiving when I'm looking at your variable descriptions this time. Okay? So what I'm looking for in the design for this one is this. Okay? So say manipulated variable, part 1 is mass. Okay? Mass will be altered by putting different masses on the end of the string. Okay? Simple as that. So I'm not looking for as big of an explanation this time, because you have to do it 3 times. Okay? For part B, the manipulated variable is going to be amplitude, I think, and then in part C, it's going to be length. Okay, so you just explain that that's being changed. Okay, what's the responding variable? That's going to be the same for everyone. Okay, what we're measuring is the period. Okay, we want to see what is the effect of what we're doing on the period of the pendulum. I mean, that's the whole point. Okay, so our responding variable, regardless of which part of the experiment we're doing, is always going to be the period, which we're not measuring directly. Right? We're actually going to let it go for 20 oscillations, I think. No, we're going to count the number of cycles in 20 seconds. Sorry, that's what we're going to do. Okay? So from that, we'll get the period. Now, how accurate can I be if I'm counting cycles? Okay, so I've got this apparatus. This is the same apparatus that you guys are going to use. Okay, sorry, not everybody will be able to see it. But, okay, so this is the same apparatus that you're going to use. Okay, you're going to have a string, a protractor, a retort stand, and a ring clamp. Okay, and you're going to have a mass. Now, you're not going to do it this way on the side of the desk. Why? Well, no, you're going to be at the edge. I just had it set up the right way before when it was on this edge of the desk. Why was that better than this edge of the desk?
More space, more area for it to be that edge of the desk has a slight dip in it.
Your desk is tilted. Okay, it's tilted back towards you, so this end is higher than this end. So you don't want to run this pendulum experiment on this tilted side. You want to run it on this side. Okay, as you can see, the string is not at 90 degrees right now. Right? It's a couple of degrees off. When I had it here, it was at 90 degrees. Okay, so if there's a few degrees, like 3 or 4 degrees difference, okay, on that. So we don't want that. So we want to run it on the front edge. But okay, what you're going to do, okay, when you're trying to count the number of cycles is, I would say you can probably get to the nearest quarter of a cycle. Okay, because remember, one full cycle, we're going to start it out on the edge. Okay, one full cycle goes through equilibrium to the other side, back through equilibrium to the side we started from. Okay, so I would say you can be accurate to the nearest quarter of a cycle. So somewhere between here and equilibrium would be 1/4. Okay, somewhere between here and equilibrium would be 1/2. Okay, somewhere between here and going back to equilibrium, 3/4, and somewhere between equilibrium and returning back, a full. Okay.
Should we round up or round down? Like if it's...
No, you need to tell me, are you to the nearest quarter of a cycle? Don't round up or down, to the nearest quarter of a cycle. If it's in that sector, that's 3/4 okay, or it's a whole cycle,
Okay.
okay? So you kind of have to estimate. Was it closer to the middle? Go with 3/4. Was it closer to the edge? It's a full cycle. Okay, everyone follow me on that? Does that bring in a source of error?
Yeah.
Okay. Okay, think about your controlled variables. Okay, in each trial, you'll have some that will stay the same and some that will be different. Okay, when you're testing the effect of mass, you're going to keep the length the same. Okay, gravity is always going to be the same. Okay, and amplitude will be the same when you're testing mass. And then when you're testing mass, you'll have to keep length. I already said that. When you're testing amplitude, you'll have to keep the mass and the length the same. And when you're testing length, you have to keep amplitude and mass the same. So you're going to have that little bit of explanation there in the control. So I'm not looking for as detailed of an explanation of how it affects the experiment just when it's controlled. Okay? Everybody with me there? So I'll be far more forgiving than usual on that. Okay, for our hypothesis. Okay, if and then statement that tells me what factors you think will affect the period of a pendulum. Okay, so in the if part, tell me what factors. Okay. Factor or factors, okay, affect period. Okay, and describe the experiment, same as we always do. Okay, then, okay, tell me how. All right, so if you think that amplitude is going to affect the period of the pendulum, they say the wider the swing, the longer the period will be. Okay, if you think that mass will, heavier the mass, the shorter the period. Whatever you think is going to be, you tell me that in the then part. Spoiler alert, you already know the correct answer. Okay, so you can probably explain that already. Okay. All right, so the experiment itself is pretty straightforward, but you do have to read and follow the instructions carefully, okay, in order to get good data. All right, so you're going to, when you're doing mass and period, you're obviously going to replace the mass with a certain, with the next prescribed mass, which are all listed here. Okay, and it does tell you that it wants the length. Oh, it doesn't say what length. Let's say that we want the length to be 50 or 0.5 meters. Okay, so when we're doing this, we want the length of the pendulum, and we're just going to say it in here. The length of the pendulum is 0.50 meters. Okay, it'll be 0.5 meters for all of the masses that you test, and the masses are listed in the table. Right? So you're going to do trials with 50, 100, 150, and 200. Tegan, question?
It says for part B and part A, the length of it's going to be 0.8 meters.
Oh, does it? Okay, so I put it in your Google Doc then. I did? Okay, 0.8 is what it says.
But I don't know if it has it for part C.
Well, no, part C, you're testing length, so you're doing different
Oh,
lengths.
okay.
So 0.8 meters. There we go. Now we have it prescribed. Okay, so we're going to have the length of the pendulum, 0.8 meters, okay, and you are going to time or count the number of cycles in 20 seconds. So you're going to time 20 seconds, say go, and the person's going to go 1, 2, 3, etc. Okay, until they get to, okay, 4.5. Whoop, done. Okay, it was 4.5. Okay, and then you go with that. Okay, from there, okay, you can calculate the period because you'll know the time for X number of oscillations. Take the time, divide it by the number of oscillations, and you have the period. Okay, and then for frequency, okay, that's just going to be 1 over period. Okay. All right, and I think it says to just do, yeah. Yeah, so you only have to do 1 trial. Okay, for each mass. Okay, so that one's easy, just tie a different mass on. When you're measuring your length, okay, where do you need to measure to and from? So on my pendulum here, I would probably say I want to measure from right here because this is the pivot point to the center of the mass. Okay, that is where the length of your pendulum is always measured to, the center of the what's the mass called? Starts with B, first name spelled the same way, yeah, Bob, forward and backwards spelled the same. I had a buddy, anytime someone told him his name was Bob, he'd ask me to spell it backwards. It was a dad joke before he was a dad. Okay. All right, for your, so when you've done all your masses, then you're gonna move on to part 2, okay? And I think, does it also say in your Google Doc what angle to use? I think it does, 15 degrees? Yeah, okay. So in order to do that, okay, you need to make sure that you're looking as straight on as you can, okay? Move it out 15 degrees, okay? So that would be to there, right, to 85, and make sure it's nice and straight, and then let it go. You do have to be mindful that it doesn't hit anything while it's swinging. Yes?
Yeah.
Okay. All right, so part 2, amplitude and period. Now you use the same mass every time, it's 200 grams, okay, and you're going to use these different angles, 5 degrees, 10 degrees, 15 degrees, and 20 degrees, okay, see if they affect the number of cycles / period, okay, fill in the chart. And then for part C, it's length. Now, with length, don't cut the string, okay, because I have people like, they take, a string, and then they do the first one, and then they come back and they get another string, and they do the shorter one. Just tie the knot in a different place, okay? And then we save resources, right? So you can use the same piece of string for the whole experiment, just keep tying it here. It is a bit of a pain in the neck because you have to keep, fooling around with the protractor, okay? But it'll still work. All right, everybody clear on what we're doing? It really shouldn't take too long to get the data, okay? You just, once you get the hang of the setup, it should be pretty straightforward. So every group needs a retort stand, okay, a ring clamp, a string that's about what's our longest length?
1 meter.
1 meter, and then each time you're decreasing it by a half. So you have a meter, a half a meter, 25 centimeters, 12.5 centimeters. Okay, so you'll just shorten it, shorten it, shorten it. Okay, so make sure you get a piece of string that's a meter and a half long, just so you've got room for knots and stuff. Okay, questions? All right, we'll talk about the analysis once we have the data. So let's collect the data first. Somebody can use my setup, whoever gets to it first, don't fight. Okay, so for the analysis, guys, it's pretty straightforward. You're plotting me 3 graphs. Okay, you're going to plot a graph of each part of the experiment. So one will have mass and period, one will have amplitude and period, and the other will have length and period. Okay, obviously period is the responding variable, so it always goes on the y-axis. Okay, put your manipulated variable on the x for each one. Okay, and then explain what's the relationship that you see in those graphs. And you should already know what those results will be, okay, based on what we did. And then conclusion and evaluation, same as always. Okay, list your sources of error, how they affected the experiment, what we could do to fix them. Okay, and then conclusion, copy paste your hypothesis, explain why you accept or reject. Okay, just so we don't run out of time here. Okay. All right.